In this section 11.6, we're going to be looking at events in our probabilities that have the word not and the word or. We'll also be discussing odds, which is a type of probability. Let's look at not. Now, when we're trying to figure out the probability that something will happen, so for any event E, either it's going to happen or it won't. So when we add those two probabilities together, we should get 1, which is like 100%, right? There's a 100% chance that either it will happen or it will not happen. Now this is an equation. If I wanted to subtract the probability that our event does not happen from both sides, then I get this second equation. The probability that an event will happen is equal to 1 minus the probability that it does not happen. Or I can take that first equation and subtract the probability that the event happens from both sides, which gives us our probability for an event not happening. That would be equal to 1 minus the probability that it does. And you can use any of these formulas. Our focus will be on this last one. The probability that an event does not happen is equal to 1 minus the probability that it does. So using this not formula is not required. You don't have to, but sometimes it does come in handy. Let's look at example 1. If you are dealt one card from a standard 52 card deck, find the probability that you are not dealt a diamond. So again, this is a probability. We're going to write a fraction. In the denominator, we're dealt one card from a standard 52 card deck. So in the denominator, there's 52 possible cards we could get. This is a not delta diamond. So what you could do is you could count all the cards that are not diamonds. So that would be 3/4 of the deck, or 39 cards out of the 52, which would be 3/4. Or you could use the not formula. So the probability that you're not delta diamond, that would be equal to 1 minus the probability that you do get a diamond. So that's 1 minus probability is a fraction. We have 52 cards. How many of those are diamonds? That would be 13. So when you do this math, you're going to get 39 over 52. So remember, these are fractions. You have to find common denominator. So you're going to be replacing the 1 with 52 over 52. We'll do another example where we're using the not formula. Again, remember the not formula is optional. You don't have to use it. It just sometimes it's easier to use a not formula than it is to count all of them up. Example 2, we have this chart, and this chart is going to show the distribution by age of the 191 million drivers in the United States. If a driver is randomly chosen, we want to find a probability, and we're going to express these as simplified fractions, that the person is not in the 50 to 59 age group, which would be part A, or part B, is at least 20 years old. Part A, we have a not in the 50 to 59 age group. When we look at the 50 to 59 age group, there's 31 million drivers there. But we don't want that group. We want all the other groups. So the probability, which again is going to be a fraction, where there's 191 million drivers to choose from, so that's the denominator. So my option is to add up all the other millions, or I can use the formula that this would be 1 minus the probability that we are in the 50 to 59 age group. So if I was going to figure out the probability that we're not in the 50 to 59, and I was going to use the formula, it would be equal to 1 minus the probability that we are in that 50 to 59 age group, which would be 1 minus the fraction of 191 in the 50 to 59 age group would be 31 million. So again, you'd find your common denominator, do the subtraction, and you'll get 160 over 191. This happens to be reduced, so this would be the probability. Otherwise, you can just count up 19 million, 13 million, 6 million, 9 million, and so on. Let's look at part B. At least 20 years old. So that would be the 20 to 29, the 30 to 39, and so on. It would be everything except 19 or younger, which is 9 million. So another way to see this is not 19 or younger, and I could use this formula where I could take 1 minus the 9 million over 191, which is 182 over 191, and this is reduced. Then that not formula is optional. You don't have to use it. Let's move on to or. We have to be careful whenever we're dealing with or. There's two types. The first type we're going to look at is what we call mutually exclusive events, and it's exactly what it sounds like. If you're looking at two events, we'll call it A and B, and let's say they cannot occur at the same time, then they are mutually exclusive, meaning they exclude each other from happening. For example, let's say that you toss a coin once and you're looking at getting heads or tails on one toss. We could look at getting heads as A, getting tails as event B. Notice that when you toss the coin once, it's impossible for it to land both heads and tails. So since these can't happen at the same time, they exclude each other from happening. They're mutually exclusive. The formula that we use in an OR probability with mutually exclusive events is an addition formula. Now, most of our probability formulas are strictly multiplication. This is one of the, and you see the counting problems that we looked at as well with 11.1 through 11.3. Those are all multiplication. With OR, it's actually an addition problem. If you have two events, A and B, and you want to look at the probability of A or B, then you figure out the probability that A happens and you add it to the probability that B happens. So it's one of the rare formulas where we're using an addition. Now, in your ebook, you might see this set notation. And I don't know if you're familiar with that U-looking symbol. That's actually the word or, it's the union. We don't cover set notation in Math 100. This is actually from Chapter 2. If you want to review Chapter 2 again, you can. The only reason why I have this in here is because it may show up in your textbook. So the set notation you can ignore and then just look at the word or instead of that weird U, which is simply the union symbol, and it also means or. Example 3, if you roll a single die once, what is the probability of getting either a 1 or a 2? So you see this is a probability, and there's two events, rolling a 1 or rolling a 2. So this would be like your A, rolling a 1. Event B would be rolling a 2 in that OR formula. So I am going to use the probability notation and write the probability of having a 1 or 2 when you roll a single die once. That's equal to the probability of rolling a 1 plus the probability of rolling a 2. And these are mutually exclusive because there's no way you can roll a die once and get both a 1 and a 2. So since they're mutually exclusive, I'm going to use this formula. The probability of rolling a 1 is 1/6, plus the probability of rolling a 2 is also 1/6. So common denominator 6, this becomes 2/6, and that reduces to 1/3. So that would be the probability for mutually exclusive events. Now we want to talk about events that are not mutually exclusive. So not mutually exclusive, that just means that they can occur at the same time. Okay? So they do not exclude each other from happening. Here's an example. Roll a die once, and you want to look at getting an even number or a 2. Okay? Notice that these are not mutually exclusive, because if you roll a 2, then that is an even number. So you have an even number and a 2. Not mutually exclusive events have a longer formula. And this longer formula, that can actually be used for mutually exclusive events as well. So you can always use this longer formula. However, if you have events that are not mutually exclusive, you can never use the shorter formula. So let's say that you have events A, B. They're not mutually exclusive. And then the formula would be P, the probability of A or B is probability of A plus probability of B. Now, since these are not mutually exclusive events, then it could happen that you've counted something more than once. So you also need to subtract the probability of A and B occurring at the same time. Now below is our set notation, which again, that's from chapter 2. It may be in your textbook in this section, but you may ignore this set notation. So that has to do with unions and intersections. Example 4, we have a group of 60 students. Let's say 34 take math, 30 take English, and we also have 22 students that take both math and English. So if one student is selected at random, find the probability. So it's a probability, and again, I'm doing my thick line. Find the probability that the student takes math or English. So this is an or probability. We're looking at the probability that if we pick a student, they're taking math or English. Are these mutually exclusive events? Meaning, if you pick a student, is it possible that they're taking both math and English? And the answer is yes, because 22 of these students are taking both math and English. So this is an example of events that are not mutually exclusive. So the formula would be figuring out the probability that a student takes math plus the probability that a student is taking an English course. But we may have counted a student twice. So we're going to subtract off the probability that the student is taking both math and English. So the probability that a student takes math, well, we have a total of 60 students, so that would be in the denominator, that would be our 60. 34 students take math, so 34 out of the 60 are taking math. Plus, again, we have 60 students, 30 take English, so the probability that a student takes English would be 30/60. But then we need to subtract the students that are taking both math and English because we have counted them twice. So out of the 60 students, 22 are taking both math and English. So luckily in this formula, we have this common denominator already built in. So when we do the 34 plus 30 minus 22, that should be 74 minus 22 or 42. Which again, we have to reduce to 7/10. If you're unsure whether the events are mutually exclusive or not mutually exclusive, just use the longer formula. So I'm going to go back to example 3. Where you roll a single die once and you want to find the probability of getting a 1 or 2. What if we use the longer formula? That would be the probability of getting a 1 plus the probability of getting a 2 minus the probability of rolling a die once and getting a 1 and a 2. Probability of getting a 1 is 1 over 6 plus the probability of rolling a 2 is 1 out of 6. What is the probability of getting both a 1 and a 2 when you roll a die once? 0. So in this longer formula, if the events are mutually exclusive, then you'll always get 0 on the AND portion of this formula. But we would still get 2 over 6, which is 1/3. So again, you can always use a longer formula if you're not sure if your events are mutually exclusive. If they are mutually exclusive, that last piece will just turn into a 0. Now we're going to move on to odds. And if you are familiar with odds, it's usually used when you are gambling. So again, with the gambling. When we write odds, we don't write the final answer as a fraction. We may start as a fraction, but we write it using a colon or the word 2. In this box is the formula for going from a probability to odds. So let's say that the probability of an event happening is P of E. Then when you figure out the odds in favor of that event happening, it's a fraction where you have the probability that the event happens is in the numerator. The probability that it does not happen is in the denominator. So you're comparing these two things in this ratio. Odds in favor would be event happening over event not happening. Odds against an event happening is the reciprocal, or you just flip it. Odds against would be the fraction probability that it does not happen over the probability that it does. Again, when we write odds, we're comparing two things. So the final answer would be a colon or the word 2. We do not keep them as a fraction. Okay? If you see a fraction, it's going to be assumed that it's a probability, it's not an odd. Example 5, let's say you're dealt one card from a 52 card deck. Find the odds in favor. So again, be careful with the language and what it's asking you to find. It's not asking you to find a probability. It's asking you to find odds in favor of getting a black king. And then part B would be find the odds against getting a black king. So let's look at A. The odds in favor would be the probability that you get a black king over the probability that you do not get a black king. All right, so what is the probability that you get a black king? Well, there's 52 cards in the deck. 2 of those cards are black kings, the king of spades and the king of clubs. So there's 2 out of 52 ways that you can get a black king. That would be its probability. The probability that you do not get a black king would be 50 of those cards are not black kings. So it's 50 over 52. Notice I am not going to reduce those fractions, the 2 over 52 or the 50 over 52, because in algebra, whenever you have, and this is a complex fraction, we have fractions within a fraction. So whenever we have a complex fraction where the denominators, top and bottom, are the same, they can cancel. And this is simply equal to 2 over 50, which I would reduce to 1 over 25. And that is not the answer because these are odds. I do not keep them as a fraction. I write it as 1 with the colon, 25. Or I could use the word 2. 1, to 25. So why do we need both of these? Well, again, we'll go back to gambling because that's always fun. Let's say that I bet $2 that I would be dealt a black king. If I'm not dealt a black king, I lose my $2. If I am dealt a black king, then the odds are 1 to 25. So if I put in one $2 bet, then I get back 25 $2 or $50 back. So when you have odds, you have two bits of information. So there's one way to get what I'm betting on, 25 ways to not get what I'm betting on. Okay? Let's try part B. I want to find the odds against getting a black king. Remember, I could simply look at the reciprocal. If it's 1 to 25 that I in favor of getting a black king, then it's simply 25 to 1 that I do not. Or you could use the word 2. Otherwise, you can compute it using the formula. The probability of not getting a black king over the probability that you do get a black king would be the probability of not getting a black king would be 50 out of 52. Probability of getting a black king would be 2 out of 52. Again, denominator cancel since it's the same, and you get 50 over 2. Oops, why 20? I don't know. 2, which would be 25 over 1. Now, I would not write that as simply 25 because odds you need the two pieces of information. I would write it as 25 to 1. Okay. One more example. Example 6, let's say that the winner of a raffle will receive a 2-year scholarship to the college of his or her choice. If 1,000 raffle tickets were sold and you purchased 5 tickets, what are the odds against your winning the scholarship? So this is looking at odds against. So remember, the odds against would be the probability that you do not win over the probability that you do win. The probability that you win is easier for me to figure out because I know that there was 1,000 raffle tickets sold, so that's the denominator of my probability, and I have 5 tickets. So there's 5 out of 1,000 ways for me to win. So not would be 995. So you could just use a not formula for that. Same denominator, which should always happen if you've done your math correctly. And that would be 995 over 5, which reduces to 199 over 1. And that's not my final answer. It would be 199 to 1 odds that I do not win the raffle. So winning the raffle would be 1 to 199. Just be careful on my lab if you're asked to find odds in favor or odds against. Well, let's say that we already have the odds. And instead we want to go back to finding the probability. So you need odds in favor for this formula. And let's say the odds in favor are going to be A to B or A colon B. Then to find the probability that your event does happen, it's going to be A over A plus B. It's a very simple formula to use. Let's say that example 7, the odds against a particular horse winning a race are 15 to 1. What is the probability, so we need to find a probability, that this horse will win the race? So to use this formula, remember, I need odds in favor. I have odds against as 15 to 1. So I need the odds in favor. So remember, odds in favor means you just flip it. So this will be 1 to 15, which means that the 1 is my A and the 15 is my B in this formula. The probability that the horse will win, that's what I'm trying to find, is going to be A, or 1, over A plus B, 1 plus 15. It would be 1 over 16. So again, just to caution, make sure that you're clear on what you're being asked to find. Are you asked to find the odds in favor, the odds against? Are you asked to find the probability and you're given odds against or odds in favor? That's it for this section. The last section that we're going to cover is 11.7, and that's where we'll be looking at some other interesting probabilities. It's probably the most complex section, and then that's the end for our chapter 11. So that's it for this section.